to apply the phosphate in the bracket. Okay? So,
No, 300.
310. 310.
310.
310.
Hey, this is a pass.
It should be 310. Point
Yeah, okay,
three.
if you're able to point out the mistake, then it means you know it. Okay? Yeah. Once you're able to spot the mistake and correct it.
If you put it in your bag. They're so good.
What is that, Asa?
Krispy Kreme.
All right, number 14. Covalent or ionic?
Covalent.
It's a double.
Covalent.
Number 14. You're lost. You're checking something. I'm also checking something with you. What is it? The ionic or covalent?
You can write it here.
You can see, bring your worksheet out.
That's copper.
Oh, I beg your pardon.
Because it's made of
Non-metals.
So it's
Lots of
like-
our book non-metals. So if you want to
one.
name this,
Yes.
what will be the name?
See.
Kira?
Yeah.
Yes. That's why I'm picking on you. Name it. Now it is
Oh.
covalent. So how do you name it?
40.
I don't know. Five.
Ah, yeah. This is plus.
Four.
Okay.
And then, because this is in a bracket, that means whatever is the chemical space.
Diphosphorus trisulfide. Okay, we can have a white sulfide and not sulfate. Good. Sulfate is polyatomic ion, SO4 with 2 minus.
Is that right?
It's right before you.
Hydrogen is 1 times.
Okay.
Oh, yeah.
So sulfate is a polyatomic ion, SO4 2 minus.
Mm.
But sulfide is the ion of sulfur, which is -2.
Yeah.
S -2.
Because this is
Okay.
10 times 2.
So when we are naming the covalent, the first covalent
16 times 2.
or the first non-metal maintains its name, but the second one
The H.
will change or will end with I.
Because hydrogen
Then
is
also you shouldn't forget
1
the
times.
prefixes. 2 means die, 3 means try, and so on. If you have only one for the first element,
Thank you.
you don't say mono. You just mention the name of the element. But if you have one for the second element, you have to state mono. Okay? One more. One more. Where are you? 17. Okay, that's 17.
Explain it
Is
to me.
it
Which one?
ionic
This
or
one.
covalent?
Ionic.
Which one?
It's ionic.
Why ionic?
Because it has a metal and non-metal.
Okay, metal and non-metal. Sodium is metal. Which is a non-metal?
Sulfide.
Sulfate.
Salt.
Sulfide. Sulfide.
Sulfide, yes, sulfide.
Why sulfite?
SO3.
SO3. SO4 is spit.
Okay.
Three is spit. Sulfate. Sulfite.
Sulfide.
So what's the name?
Sulfide.
Sodium sulfide.
That is it. Sodium sulfide. It's in the case of the that's what the Yes, sodium hydrogen carbonate, sodium bicarbonate, both correct. Sodium hydrogen carbonate. Remember, sodium carbonate. What is hydrogen? But it says hydro means water. Hydro means water. Is somebody okay with that?
The 20, is it di?
Hydrogen.
Is it dihydrogen sulfide?
No. Clearly it's not.
Yeah, it's right. But it has a common name. Hydrogen sulfide. Okay, that's not sulfuric acid. But you can make it dihydrogen
Monosulfide.
Monosulfide.
sulfide.
So is it both then?
Hydrogen sulfide, okay.
No, what I mean here, is it both? Is it ionic?
Yeah, I said it has a common name, hydrogen sulfide.
Hydrogen, so that means it's
That is that one.
ionic.
You can also use the systematic way of naming it. Dihydrogen monosulfide, according to the rules. Okay.
Sir, when we
Hey, let's do everything. Okay, number 19.
8.
diboron.
Boron hydroxide.
Boron.
Hydroxide.
Diboron hexahydride. Hydride.
Hydride.
Hydride. Good.
Wow.
Who said hydrogen? It's a hydrogen.
Wow. Taking on me already.
So,
No, I think it was Serian actually. It
Hydride.
was Serian. It was Serian.
Okay, let's see. Number 6 and 7.
Yeah, that one. Is it magnesium carbonate?
Brilliant.
Sorry?
That's correct.
Magnesium
Carbonate. Magnesium carbonate.
Is it number 7? Is it like phosphorus and
Pentoxide.
pentoxide?
Yeah. Phosphorus pentoxide.
Amazing.
Wait, so when writing it, you don't write the, okay, fine, right.
Number 15. Number 15 and 13.
It's okay.
Number 15 is what?
Oh, now look what I've done now.
Hydroxide.
That's what, when you don't mind your business.
What is the thing I gave you?
So I just mind your business. What
Yeah.
happens when you don't mind your business?
It's a very old pencil.
Yeah, I put, that's why she has highlighted.
Maybe this was a bad idea.
Yeah, give me a postcode. that's all. Number 15, 13 is what?
Iodine pent.
Iodine pentafluoride. So when it comes to the naming,
Yeah.
fine.
Oh,
Now,
whoops.
I give you the name, you write the formula. Okay? I give you the name, you write the formula.
I think you know better than me, sorry. Your pencil was fine. So that's actually.
So go to this page. Ask for the management speed. I'm not going to the ionic one. Beautiful one.
Which one is that?
Okay, I'm going to show you. Okay, moving on.
Probably just doesn't like me. Or maybe my sharpener is old as well. So
There we go. Here we come.
usually old has to pair with more vibrant. So I think it's still.
I give you the name, give me the formula. All right, how many are we? Everybody's coming to the board. 1, 2, 3, 4, 5, 6,
Oh my
7,
God,
8, 9,
don't do
10,
that to
11,
me.
12, 13, 14, 15, 16. You have 16 of these. 1, 2, 3, 4.
We're waiting for Linda as well.
8, 9, 10, 11, 12, 13, 14, 15. Oh, exactly. More than that. So pray that you get a super one. All right, starting from where? The back.
Oh gosh.
Then you start. Come. First one. You want to push the subject?
Wait, what are we doing?
I'll start with you. Magnesium chloride. Come and give me the formula. Right?
Oh gosh. Thank you.
Right, magnesium chloride. magnesium and chlorine. Magnesium bonding with chlorine. Remember ionic bonding. And then ionic bonding. Eh? Is she right?
There's 2. Magnesium is 2 plus.
Magnesium chloride.
2. No, chloride. Yes.
Why should you be there?
Magnesium is 2 plus.
Because magnesium is gonna give the electron. I mean, it's gonna
I need to
magnesium
understand this.
an electron that it needs to give away.
Everybody, pay attention here. We get it ionic bonding. Apply that concept. Magnesium chloride is a bond between magnesium and chlorine. Ask yourself, is magnesium a metal? Yes.
Yes.
Chlorine non-metal? Yes.
Yes.
So that is ionic bond. If it's ionic bond, then there should be a transfer of electron from the metal magnesium to chlorine.
Yes.
How many is magnesium going to give out?
2.
2. Chlorine can take how many?
1.
1. So for magnesium to transfer all the 2 to chlorine,
You
we
need
need
2
2 chlorines. Okay?
Yeah.
So that is correct for now. And that's the principle. Magnesium is ready to give out 2. Chlorine can take only 1. So for magnesium to bond with chlorine, another chlorine must have to add up and take the extra 1. So MaCl2, magnesium chloride. Sulfates, aluminum and sulfate. Aluminum sulfate. Finish. Back away. And you are clapping.
Oh, sorry, sir. You should clap.
What is sulfate?
SO4
SO4.
negative 3.
SO4. SO4 2 minus. So the sulfate is coming with -2. SO4 -2. But
Aluminum.
aluminum is ready to give how many?
3.
3. Sulfate can take only 2. So for aluminum to bond with sulfate, what should happen? You have Al3 and then SO4 2 minus. How should that be possible?
We need 2. We need 2 aluminum.
We need,
2 aluminum.
and then to bond with 1 sulfate.
No, 3.
We need what? To bond with 2 sulfate. So 3 aluminum, eh?
3.
Okay, aluminum.
We need 2.
1.
Aluminum is going to give out 3, sulfate will take only 2. 2 aluminum and 3 sulfate. So that we create a total of 6 minus 6. Okay, minus 2 minus 2 minus 2 give us a total of -6. So 2 of this give us a total of what? Plus 6. Plus 6 minus 6, 0.
Yeah.
So for aluminum to bond with sulfate, we need how many of aluminum?
2.
2. And how many sulfates?
3.
3. The sulfate is a polyatomic ion, so it's 1 entity. Does that make sense? All right, Nelly. Diboron tetrabromide. Diboron tetrabromide. Diboron tetrabromide. couldn't write the BR like a video. Diboron tetrabromide. Yes, next. Potassium chloride. So, oh, you have to hear it before. Yeah, come again. Potassium bromide. So I'm coming this way. You can guess which one they are going to do. And start with I will dodge you. You say, oh, let's see this one.
Oh my god.
I will dodge you.
Mm.
Potassium chloride. Okay, that's good. Sodium chloride, yes. Sodium chloride. Sodium chloride. What is that close to you? Jesus died young than you. When you write a form, I don't show the charges.
Okay.
Is that okay?
Mhm.
The charges go to 0. That's why we don't write it. If it is an ion, then you have to write the charge. Yeah. So sodium chloride. Yes. Good. Sodium chloride. Chloride. Sodium chloride. Sodium chloride. All right, so now you know the trend. Are we going this way, coming that way? Okay, yes. This is sulfur dioxide. Sulfur dioxide. Sulfur is looking at that. Your mom said you. Okay, your mom should know you're in a lesson. Yes. Oh, baby, you should know you are in a lesson. It's not your mom's fault. Okay?
Why,
Yeah. I should say it that way, right?
you know,
Yes.
why is sodium chloride ClO2?
Chloride.
Why is O there?
Y-O. Yes, who can help her? Chloride. Chloride. Polyatomic. It's not fluoride. Chloride. I didn't ask you to send another one last. PlO2 minus is chloride. The one above chlorate. Chlorate. Yeah. But don't worry about it too much. We're not going to look at that. This is just one of it. The sulfur dioxide, good. Then the other thing is ammonium chloride. This is how I'm going to trace the thing. Ammonium chloride. Yes, the next one is copper 2 oxide. Copper 2 oxide. Ammonium chloride. That's good. Ammonium chloride, good. Copper 2 oxide. Starting from the center. Yes. Copper 2 chloride. Copper 2 oxide. Yeah. Copper 2 oxide.
What did you like for this one? Is it?
SN2.
Copper 2 oxide.
SN. SE.
Oh,
So that's if you are
No, SN. And then SE.
oh, sorry.
SE.
FE.
Copper 2
Yeah, SN.
oxide.
Yeah, and 2.
Oh, and
With the two. No, with the two.
okay.
Without the N.
Negative.
Oh, sorry. Okay. Beg your pardon.
Copper 2
Okay. Got you.
outside. Is it right? Let them see. This is copper 1 outside.
Now,
Did you get that? What you got?
CuO.
CUO.
What did I tell you about this? Iron 2, iron 3, copper 2. When you see those things. When you see copper 2, what does that mean? Plus 2.
Yeah.
So it means copper has lost 2 and is bonding with oxygen. Oxygen will take how many? 2. So what should be the formula?
CuO.
Zero. You understand it?
yeah.
Yeah.
Copper 2 means it has lost 2 electrons. And if it's bonding with oxygen, oxygen is in group 6, it is. So the 2 electrons get with oxygen. Yes. Maybe it was me. Now, once you are forming the compound, the total charge should be 0. Okay, it says zinc 2 bromine. So zinc 2 means it has lost 3 electrons. Bromine is in group 7, it needs 1. So Br minus. Therefore, we need 2 of this. So it becomes zinc Br2. No charge. Okay, so this one is right now. Where are we? Nitrogen tribromide. Here I've already do this, I'll leave it. Oh, you want to come?
Well, I'm just saying.
Yeah, come and do it.
Do it?
Yeah. Nitrogen tribromide. What does B stand for?
Boron.
Oh, wait, yeah.
That's it. Bromine. Bromine.
Think
Alright,
it
so,
might go to me.
Potassium,
Oh my God.
potassium chloride.
Kira, you took the one I wanted to do. Now you've left me with the hard ones. This is not good for me.
The
Yes.
next person follow with potassium nitrate. Follow.
Oh,
Yes, calcium chloride. Come on. Distinction. Potassium nitrate. Carbon monoxide. Follow. That's why you were smiling.
Carbon monoxide.
Potassium nitrate, good.
What's Tina talking about?
Carbon monoxide. Right,
carbon monoxide, is it CO?
CO.
Okay.
Write your own C.
Is it someone else's C?
Yeah.
Alright, silicon dioxide.
I need to go to the
Silicon
bathroom.
dioxide, follow, potassium. Oxide. The silicon dioxide. Silicon dioxide.
Oh,
Thank you. Next, yes, ma'am.
trust
Potassium oxide. And the next one, the last one, they are ending very well. Same for selenite.
Just need to get this one.
Selenite. Yes, potassium oxide. Oh, why you laughing? Potassium oxide.
Potassium plus 1. And oxygen minus.
They said you are wrong, so go ahead. Is she right?
Yeah.
No.
Two versus
You yourself, are you right? Are you right now? You are right now. You are right. Okay, is she right? They said no.
They said no.
Are you right now? Are you right now? Why do that? What is what? Can leave one electron and what? And oxygen. Can take two.
Yes.
Uh-huh.
So.
So
Yeah.
are you right? You sure? Confident? You sure? You sure? 10,539. Selenium, is it selenium? Yeah, selenium is sweet blue. SE, blue 6, okay. That's good. 10 is 5. 10 is 5, so it's ready to give out 5. Oh, sorry, I before. 10, 4. So 10 is ready to give out 4 electron. Selenium to take 2. So how would it be? Yeah. Is it right? Selenium will take 2. So I think it's ready to give 4. Yeah, then she's right. Anyway, are you yourself right? What makes you right? Yeah, share it. You don't say yeah, share it. You also say yeah, share it. I didn't tell you yeah, share it. 10, 5 means 10 is going to give out 5. Selenium is in group 6, it will take 2. So if one selenium takes 2 from 10, we are left with 2 boxes. So another selenium will come and take those 2. So that's correct. SNSE2. Okay? All right, that's fine. We are moving on to
How nerve-wracking.
Is it this one? Is it this one?
Yeah.
Sodium dihydrogen phosphate. It's easy. Sodium dihydrogen phosphate. Don't you know this? You know sodium.
Is it Na?
I don't understand why you got this one.
You see that?
Yeah, me too.
Phosphate, what's the charge of phosphate?
Maybe I was already too sneaky.
BO4, BO4 3 minus, okay? And then we have sodium, which is Na plus. Dihydrogen, 2 hydrogens. So each one is plus.
They all come to that.
So 3 cancel that. So we have what? NaH2BO4.
So, Mr. Inaka, my one, I put the PO4 in bracket wrong.
With a number behind or
Not
not?
like NAH2, then PO4, like that.
What's correct about that? It's not number. That's right. Okay. Let's move to today's work. All right, so today is mainly for matter. So Monday when we meet, we will continue with the move. Now we don't have to write chemical formula. Okay? We continue with the calculation of move and the rest. If anything can happen, please let me know. I think that's possible. Don't wait till we do a chunk of it and then tell me the whole truth. We are not in the same level.
Oh yeah, can you explain that to me? Can you explain that to me later?
Yes, please.
This one, yes. Not the monomers, the other one. Ionic bonds. Not the ionic
Arsenic, chem, fluoride. Arsenic, what is the symbol for arsenic? AS,
F
chem,
5.
fluoride. How many fluorine?
5.
Yeah. So AS, F5. You don't say monoarsenic. Okay. So that is that. All right. What was I doing? I was going to look at for element. We go to matter. So we are doing matter. What is matter? What's the matter with you? So what is matter? We said anything that has an occupied space, and every matter on earth is made up of elements.
Yep.
Okay, so we have four types of matter, but we are going to look at the first three in my teaching. I'm not going into the last one. We have solid, liquid, gas. Now there has been a fourth one, plasma. They are just ions. Okay. Solid, liquid, gas. You see the differences. You see the differences in their arrangement. The solids are tightly packed. Touching each other, the liquid are a bit loose, but closer to each other anyway. And then when it comes to the gases, they are far apart and they are not constant motion. And then the fourth one, plasma, is very hot, ionized gas. Hot ionized gas. Ionized means they are charged. Okay. So, phase of matter, we have the solid liquid gas.
Something happened to my brain, go right up.
And the plasma. Solid has a definite shape and it has volume. Okay? Every solid has got a definite shape. Right? I am a solid, I've got a shape. Okay? Yeah. You see some men, they will go to the gym, raise the metals, and then they become like that. That's their shape, right?
Upside down triangle.
Yeah. Upside down triangle. Then,
Okay, Carla.
solid have mass, solid things have space, and their particles are closely held together. They are not mobile, but they vibrate at one point. Is it okay? The whole thing is vibrating. The particles are not loose. They are held together. So particles are packed tightly together. They have very little energy and then vibrate in a place. Okay? Now when you apply heat to a solid, you energize the particles. The particles become excited and then they begin to what? Begin to move because they've been energized. And as they move, they go to liquid. So the process of changing from solid to liquid is called melting. Not the melting solid. So after you have applied heat to the solid, you turn it to what? Liquid. When we come to the liquid also take the shape of their container. Liquids don't have definite shape, but they take the shape of the container you put in. So, whose water bottle is this? See the shape of this? Look at the liquid inside has taken the shape of this water bottle. All right. Let's see that Coca-Cola bottle. It's not Coca-Cola. Coca-Cola. Okay. This one, if it's filled up to the brim, you see that it will take the shape of the container, how it is molded. So liquids do not have definite shape, but they have definite volume. Hello?
Aye.
Solids do have definite shape and definite volume. Okay? Liquids do not have definite shape, but they have definite volume. And they do have mass as well, because they carry weight. You have mass, liquids take up space. This is how the particles of liquid behave compared to that of solid. You see that these are more energized than the solid one. So even though they are moving around, they are closer to each other. So our loosely packed have medium energy levels, move around, and particles go around each other. When we apply heat, then we give them all energy. So this time, the movement is going to be what? Increase. And that will take us to what state? The gaseous state. So there we go. And then, when we come to the gaseous state, gas spread out to fill the entire space, giving and do not have definite volume. They do not have definite volume, they do not have definite shape. Okay? If I stand in this corner and I release my perfume, look at that. Let me finish my statement before you tell that. And I release my perfume. I mean, very soon you get it there, okay? Because the particles are now energized and they can move faster to occupy the whole space. They have mass because when those who drive, when you pump your car tire, you see how heavy it is. Yeah, because the air or the gas put in has got weight. So it has added additional weight to the weight of the car. Yeah. And the gas take up space. So here we are. You see how wide the distance between the particles are. Free movement have lots of energy. When you add heat, then we go into the plasma state, where lightning is a plasma. When it's raining, the light that you see is a plasma charged gas. Okay? Used in fluorescent lights, bulbs, and neon lights. Plasma is a lot like a gas, but the particles are electrically charged. Okay, so that takes us to what we call the kinetic theory about kinetic theory of matter. It says that kinetic is a theory it's about kinetic energy, which is the energy an object has due to its motion. Whenever something is moving, it means that the energy being used is called kinetic energy. Kinetic energy is energy in motion. Is it okay? When you are sitting down, okay, we know I say you've got potentials. There's something in you which is not yet out. It's there. So if I'm sitting down, standing there, what the energy I have is potential energy. I'm not using that energy. I have the energy. I'm static. I'm standing in one place. Okay? But the moment I start moving, the potential energy has now turned to what? Kinetic energy. Energy in motion. Yeah. So kinetic theory is about kinetic energy. And what is that theory saying? It's saying that matter, the particles of matter, being it solid, liquid, or gas, the particles that are there are in constant motion. So the solid particles are in constant motion, but we saw it vibrating. The liquid particles are in what? Constant motion. The gaseous particles are also what? Constant motion. So kinetic theory of matter says that all particles of matter are in constant motion. Right. So when you energize solid, you turn to liquid. You energize liquid, you turn to gases. You energize gases, you turn to glass.
He can be caught.
So the process of changing solid to liquid is called melting. Okay? That means heat goes into the solid as it melts. And then the opposite, changing liquid to solid, is freezing. That is heat leaving the liquid. All right? Liquid to gas, vaporization or boiling. Heat goes into it. The opposite, gas to liquid, condensation. Heat is leaving. And we do have some substances, they can change from solid straight to gas without going through the liquid state. Typical example, iodine. Okay, iodine can change from solid to gas. And that process is called sublimation. 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 All right. Let me, what is that? You don't need this. These are all examples. Right. I do not do. Alright, I don't need you. These are examples. There are several names of matter, change of state. When ice cream and melt ice cream. Chocolate and melt chocolate. So chocolate melts to liquid chocolate. These are the processes. Yes.
I think we've done that already.
So after looking at the state which
Matter, I think we've done
will
it
be
already.
solid, liquid, or gas for matter. We also going to look at some matter in the form of
Only know
elements,
atoms. Okay.
matter in the form of compound, matter in the form of mixture. So element, compound, and mixtures.
Mm.
We know the elements already, found in the periodic table, but matter is anything that has mass, and this case we said about that. Matter is made up of what? Atoms. And then an atom is the smallest unit of matter. Atoms are combined or bound to form molecules. That will lead to the compounds. If they do not combine, it leads to mixtures. So a sample of matter that has definite chemical and physical properties is what we call pure substances. A pure substance could be a molecule, an element, a compound, and atom. You don't need this, you know that already. So compounds, how are compounds formed? Pure substances composed of two or more different what? Elements. Different elements. Sodium and chlorine, different element. Carbon and oxygen, different element. Hydrogen and oxygen, different element. So these are called compounds. Okay? What is happening? They are made up of elements in specific ratio. That is always the same. But these are formed through what? Chemical bonds. So the compounds are formed between two or more different atoms or elements that are chemically bonded. That's the key word. That are chemically bonded. So we give a formula and can only be separated by chemical means, not physical. So when it's formed through chemical means, you can only use chemical means to separate them. So compounds are formed when two different or more different elements combine chemically. Combine chemically. And then a mixture is a combination of two or more pure substances that are not chemically combined. That are not chemically combined. And no chemical change takes place. Each item retains its property. So those of you who eat salad, you see the lettuce, you see the yes, I know it's salad, so tell me what are the pictures there. If you mark good, like yes,
Sweet corn.
sweet corn.
Cherry tomatoes.
Sweet corn with the salad.
Cherry tomatoes. It has sweet cherry.
Beetroot,
Yeah.
yes, what else?
Cherry tomatoes, apparently.
Tomatoes.
Avocado if you want.
What?
Avocado
Avocado.
if you want.
Okay, yes, go on.
Olive oil.
Olive oil.
Yeah, it's very Mediterranean.
Okay.
Get it, Kira.
Then I have it. Mine is people.
Zaza, anyone? Not any Zaza.
The salad is watching. Right.
My salad is what? You know
So
what?
my salad is.
I know watching.
Where are you from?
I'm from Sierra Leone.
Where?
Sierra Leone.
Oh, okay. Yeah, salad is
It's
an
a
example
complete-
of
I
a
think
mixture. You
it's
see all the
West
components at the same time. Because they are not chemically bonded, that's why you see the individuals. Okay? Yeah, but for a compound, you will not see the individual. A new thing is formed entirely. So, an element contains just one type of atom. A compound contains two or more different types of atoms chemically what? Joined or combined. A mixture contains two or more different substances that are only physically joined together, not chemically. A mixture can contain both elements and compounds. Yes, you can mix elements and compounds together. You can mix two elements, you can mix two compounds, you can mix a compound element, and so on and so forth. So let's look at these examples. Rocks, are they elements or compounds? Or mixture? Rock.
Mixture.
Rock.
Rock is an element, huh?
An element. We have an element on the periodic table called rock.
No, no, you don't.
Mixture.
A mixture of what?
Elements.
It's a mixture.
Of elements and compounds.
Yeah. How?
Different minerals.
Now we are not looking at, we are only talking about the rock. Oh, what can I look at? The rock and the water. The rock. Why is the rock a mixture? Okay, Google, fast. Rock, mixture or compound?
Mixture.
What is it?
I don't know, I've got no idea. Is it because like you can still get like separate elements from it physically, like you can break up and take certain things from a rock, but
That's why I said search.
okay.
Rock, mixture or compound?
Mixture.
What's wrong with it?
It's a mixture because it combines physically. That's what Google said.
It's combined with what?
It's a compound. Since it's made up of silicon and oxygen, joined together at a fixed ratio. Sand and
Silicon oxygen is a sand.
Yeah.
Silicon dioxide is sand. We're talking about rock. Rock is made up of sand and other stuff.
Minerals.
It has some
Crystals.
minerals in it.
Yes, sand and stone from a mixture.
Yeah, fine. Most mixtures, so okay, let's say some of them you cannot see it as a uniform. So later we are going to talk about homogeneous and heterogeneous mixtures. Okay. Now, what was the talking about? Yeah, when you put salt in the water, what happens?
It is all.
It dissolves. So then you see the salt in the water. You can see the water. You see it as water, unless you taste it. But it's a mixture. You can separate the two. Yeah. So most mixtures, or we have two types of mixtures. I should say. We come to that. Homogeneous and heterogeneous. Homo means same face. So that might be one of it. Okay, now copper.
Element.
Element good. What is this?
Mixture.
Jelly beans. Mixture.
Mixture.
Yes, what is it? Yeah, you. And with the baby. And now with the baby.
You're asking what a mixture is?
Yeah, what is this? Is it a mixture or compound or element?
I have to think about it, sorry.
Okay, better. See, you are not here.
I'm here. I'm just thinking about it.
What is that?
Mixture.
It's sweet.
It's sweet. Yeah, it's sweet.
I think it's a mixture.
Is it a mixture, compound, or element?
Mixture.
Mixture. You can see the various components.
Haribo.
This is heterogeneous.
No jelly bean.
Different phase. Okay? Table salt, table sugar, rather.
Compound.
Compound sodium chloride.
Okay. Diamond.
Element.
What element is it?
Silver. No, copper.
Diamond. No. Tea,
Mixture.
salt,
Compound.
new gas,
Element.
salad,
Mixture.
pure,
And
Compound.
real,
Element.
lemonade,
mixture.
silver,
Element.
and
Mixture.
So, these are examples. Now we have two types of mixtures. What's the type? I need you to work out.
Is it
We have two
homogeneous?
types. We don't finish at 3.
Homogeneous. Are we going right through, right? Yeah.
Let me run this out.
What did he say? He said my clock.
Yeah, finish at 6.
Oh, wow.
Yeah, we have two types of mixtures.
Homogeneous. And
We have homogeneous and heterogeneous. Homogeneous mixtures and molecules are mixed up in an even distribution. Even distribution, so you won't see any difference. Salt and water. When you put salt in water, the salt will dissolve. If you are not there, when you come and meet it on the table, you think it's water. And when you drink that, you see that it's salt. Okay? Because the solute and the solvent are mixed evenly and they use uniform. Heterogeneous are not mixed up in an even distribution. You see the differences. Alright? And you pour oil in water, you see the division, the oil settling on top, water down, so that you see two different phases. And that is an example of heterogeneous mixture. Salt in water, homogeneous mixture. So solutions, homogeneous mixture, solutions, a well-mixed mixture appears to be a single substance. It appears to be a single substance. When you put salt in water, it appears to be a single substance. Water, but never the salt in there. So anytime you form a solution, you have two components of it. A solution is made up of a solute and a solvent. Solutions are always made up of solute and then solvent. So what is a solute? What is a solvent? The substance being dissolved. Example, salt and water. The substance being dissolved here is the salt. So salt becomes the solute. And then the solvent is the substance in which the solute is being dissolved. Hence, water becomes the solvent. Water is considered a universal solvent. Why? It can dissolve almost everything. Okay, water can dissolve almost everything. Even though we say it cannot dissolve so many things. The idea is that a little bit of it dissolves into it. Water is considered a universal solvent. Particles do not scatter light, and example is a coffee, lemonade, and then Kool-Aid as solutions. Not talk about this. So we have two types of mixtures and matter. We have pure substances, which could be either element or what? Compound. And then we have the mixture, also one of the matters. The mixture could be homogeneous or heterogeneous mixtures. And these are just examples of what's okay. Separating technique will be done. Let's look at this one. Let's use the rest of the time to work and see whether we
So was this not there already a long time ago? Oh. Sarah, where's Linda? Do you know? Yeah, she's not, you don't know.
No, she said.
I text her, but I think I don't know, she didn't respond. Text her.
So, average number meters, then we select get to some element from that's among the register. And yes. Linda here.
No.
Lisa.
Present.
Asia is here. Mira. Mira is here. Cameron seems to be here.
Yeah.
Jara is here. Samuel. Leah. Joey. I saw Linda today. I was here yesterday.
Yeah.
No, so she was here.
Today,
Yeah.
they were here. Julie, rather.
No, she's not.
Two friends here. Zina. Mo. Kodo.
Yes, sir.
You know how to sing?
No.
Nelly. Don't know how to sing. Kodo Amachi. There's a musician called Amachi. You know him?
Yes, sir.
No, he can sing.
You don't need me to come up here.
They all Amachi should sing. Steven.
Yes.
Yeah. It's a dog. Who is he? Yeah. Maha. Zora. Lucy. Amro. No.
Yeah.
And then serene.
No, Mr. Enoch, no.
You know yourself. It says serene.
It's Sarian. Rian.
Serene. You want me to pronounce all the letters? Serene. What is this? Natalia.
Yeah.
Okay. Go on, man. Is a dog a mixture? Six. Dog is a mixture. Dogs. Whether it's a dog or dogs mixture.
Please say your name. Please say mine.
Are you not a
He
mixture?
never says my name.
Human.
Oh my gosh. Oh my gosh. Very much. That was my baby.
And then I send substance. I think.
Hey, did you all get the assignment? Everybody has got a copy? Yeah, so I'm going to put them. Huh? Don't have it. Yeah, I counted the number that were requested before. So how many now are there? 1, 2, 3, only 3. That's how I can have it. You are here. Right. You are here. I'll bring them.
I'm sure if I realize anyone. It's only a mixture. The mixture? Yeah.
Oh, it is a race with sugar and alcohol. We mix them. So,
No, that's a mixture, because you can separate it.
can you separate sugar?
They use something like sugar, yeah, sugar.
And alcohol?
Oh, I said something alcohol. Yeah, salt also is
He said. He said lightning. Is milk mix?
No, I don't think it's milk. Milk just comes out.
No. Straight out the cow and then just. So.
You add salt. Yeah, because that's what it is. That's interesting, yeah. Okay.
Yeah, that's what I'll do, and then you go, okay. I was like, you know, like the blue shirt has it up there. Not really good, I think it's very big. It's a good story. It's really, what it is.
Right? No, it's- you do the first selection.
I woke up at 3 a.m.
I'm just making out. Better pay.
Nothing playing.
You can't really see that.
What about you, whether they have hydrogen, price, value, price, density? Yes. All right, so let's look at it. We are reading the first sheet. Good. Is wood a mixture or compound? What is it?
Mixture.
What about the dog?
Mixture.
What? X. What does X mean?
It's mixed.
You say yes. I'm saying it's mixed. You not say it's correct. Why do you say it's X? X means what? No. Why do you put that? Why do you put a dog as a mixture? Explain. Why is a dog a mixture? Because it's a mixture. That's very nonsense. Why is a dog a mixture? Because it's a mixture. Why is a dog a mixture? Why are you as a human being a mixture?
different tissues.
It's a mixture. Yes.
Those mixed.
What I hear. What else did I say?
A dog is a mixture for milk.
Blood, water,
Oh my gosh.
okay? Blood, water, the flesh. So it's a mixture. Human being, the drink of blood and pizza.
Mixture.
Mixture.
Come on.
Mixture. I think.
Pizza.
Pizza.
Come on.
Pizza.
Pizza, yeah.
It's a mixture. It is, isn't it?
I said a mixture.
Mixture.
Compound.
I thought it was a mixture.
I don't know. It's
From
Is it
s-
a compound or a mixture?
Huh?
Is it a compound or a mixture?
Mixture.
Pizza. Have you eaten pizza before?
No.
No, you don't know.
She only eats paella.
mixture.
You do everything.
Isn't it? Yeah.
But it won't be able to confirm it, so it's a mixture or not?
Which one?
Pizza, the pizza.
Yeah, you do one before, tell me. Pizza is a mixture. Diamond,
And then mixture.
mixture,
Element.
what?
Compound. Compound.
Good,
Mixture.
guys.
Wow.
Compound.
Good, huh?
Compound.
Okay, I said,
Compound.
you can't do it. Too fast. I'm 16 Just follow. Sulfuric acid,
Compound.
bismuth,
Element.
alcohol,
Compound.
salt,
Compound.
salt,
Element.
Elements.
baking soda,
Compound.
Compound. Milk. Mixture.
rose,
Mixture. Is it? No, it shouldn't be.
No, it's not.
Oh, yeah, it is. Wait, one.
Sugar,
Compound. I put compound. I put compound.
milk,
Mixture.
gasoline,
Mixture.
I didn't put. I put mixture.
gasoline,
I put mixture.
Compound.
Compound. Okay.
What is it?
mixture.
No, mixture.
Gasoline, you can get different units from it.
So it's a mixture.
You know the crude oil, you
Yeah.
get different fractions, petrol, diesel.
So it is a mixture then.
And even from petrol, we can get
Mixture.
something.
That's why I
different from
thought
it.
that. Gosh, that's what I put
So
before.
the carbons are mixtures. They contain other stuff.
Yeah. And then uranium is
Yeah,
element.
the hydrocarbon is heavy, a little of hydrogen and carbon. And we have branches of it, we have petrol, we have diesel, we have buses, we have liquid. We have, even some branch to get it from them. Okay, and if you are short of, let's say if you are short of petrol, you can go for something that has got high, long chain, carbon chain, and then you break it, you can get that to one, kerosene from petrol, kerosene from diesel, it's possible, a matter of breaking the long chain from the carbon. But electricity. How come this is
Everyone's saying this.
this is what water. Kilowatts.
Oh, yeah.
Mixture. There's a solid. I don't know. Mixture. I don't know. Popcorn.
Pail of garbage.
Mixture.
No, popcorn. What's popcorn? It's a mixture. I put mixture.
Popcorn.
Mixture.
The dog is a mixture. He said, okay.
What's
Gold is
energy?
an element.
Huh?
Pizza is a mixture.
It's none of that.
X.
Pizza? Mixture. Yeah.
How can energy?
Concrete mixture, right? And I did not do this shit.
Yeah, that's what I done the last one. Feelings of kids. Hey, another one. It's another, that one. Okay. ILS.
Which one should we do?
This one.
This,
Sausage. Summer sausage. Mixture or compound.
Mixture.
Still,
Okay. Steve. Oh, you don't know Steve. You don't know Steve. Yeah. What is Steve? Oh, come on.
homogeneous mix.
Steve is water.
Like solution.
Water in the form of a gas.
So it's
So it's what?
Compound.
Yeah, Steve is H2O compound. Salt water.
mixture.
Solution.
Huh?
Solution.
What is it?
Solvent, no. Solute, is it?
Solution.
Where do you have to write that? So it said that steam is what vapor. Yeah, everything is vapor, water. Air water or water turned to air. Water turned to gas. So what should be the some properties of gas? No definition. No mass. It's no mass. No mass, no shape, and that it is the shape of a container. Tired, I'm tired.
Should we go?
Now, how many minutes more?
2.
We finish one. Fast, eh? Oh, okay. Yeah, continue with that.
We're done this time, actually, done now.
Let's see. Some of the answers are wrong. Go and compare.
This time I can even watch my
I've
good.
seen it that you can know. Okay, use the rest of the time to complete it. If you don't complete it, you're not leaving. So, column C. You didn't have any of them for C. Then please, sorry, the work is wrong. There should be C. And column for C.
So you can go. You can go.
Try this one again. Go and compare, go and compare. Go and compare.
What's in column C?
What did you get from that?
That's a solution. Solution?
Solution for
Yes.
Some people sleep here today.
What is column C?
Column C, let's do physical properties. Physical properties. Italian dressing can be liquid, right? No?
But that's a state.
Oh, that's the matter. Oh, yeah. Physical properties. Physical properties of Italian dressing.
What's it looking at?
So, Mr. Yana, I can see you need to open the car. You need water.
Have you done this one?
Physical properties of Italian dressing.
Just, can you just tell me that it's like?
I know. Yeah, go on. Got all the letters. I woke up at 3 a.m. so I need to go.
Solution. Yeah. All of those are solutions.
Mhm.
Italian dressing.
I'm still thinking about that.
Because it's a mixture.
Yeah.
So it's
Physical
either
property.
it's a heterogeneous mixture. So it's solution.
Is it a hydro?
In some sausage is not flat. I thought it was okay, you can try that.
You know what it is?
Color, hardness, smell.
Okay. You seem quite happy. Oh wow. Her face lit right up when she saw it. She found the physical properties of Italian dressing.
No, for this one.
Which one? Summer
So
sausage.
what are we using for this? I don't know what's the color of the summer sausage.
Ellie is gonna be here till 6 o'clock. Ellie, you're ready to go. Cameron, how do you go to Peckham? Cameron, how do you get to Peckham? Do you take the 345 or the train from Clapham Mill? Oh, Clapham, yeah.
Should we go, Diana? Thank you.
Go ahead.
Home.
I'm having like sausage roll, please.
Yeah.
Somehow I thought it was gonna be